Okay, so hello everyone. I'm Lara from Iprosima, and today I'm going to host this artificial intelligence integration working group. In the document I'm sharing, please write your name on the attendance list. Also, you can add some topics to the miscellaneous section. As a recap, on the last AI working group, our colleague Raul Sanchez talked about the projects ALMA and Sustain ML. And also, we saw a use case about serving models to ROS to robots. And in these working groups, I'm happy to say that we'll be at ROSCon in Japan, and we are very excited about this amazing trip. ROSCon, as you probably know, is a chance to spend an extraordinary 2 days learning from and networking with the ROS community. Okay, so we'll be there in Kyoto attending some amazing talks, such as this one of Edge Impulse called ROS to Edge Impulse, Embedded AI in Robotics Applications by Abby Brown. And also we'll be attending the one called Meet Mini Paper, the miniature-led ROS robot by Sachin Guruswamy from Luxonis. And for today, we have a very amazing presentation from CloudConstable. Mike Pickering and Hassan Baya will talk about the company, the lab research, and finally, they will show us the military avatar area. And to see the demo in a correct way, it is recommended to pin in the middle of the screen both Hassan's screens. And in this way, we will be able to see Avia avatar, and also we see the ROS development scenario. So, Mike, I saw that you entered.
I am here.
Yes, I know. Hello, how are you?
Hi, Laura. I'm very well, thanks. And how are you?
Okay, fine, really.
So apologies, you can't actually see me. I'm streaming the view of the Ava avatar system. And you can see, or you may be able to guess from the view here, we are actually live streaming from a military museum. The military museum that we're in right now is actually open to the public. And we're right at the main entrance. So if any visitors come by, we may have to momentarily interrupt the presentation so that they can get let in and see the museum. But this avatar system actually runs normally to greet visitors. So we've kind of taken it over for today for the purposes of this demo. And in this case, we don't actually have a robot to run it on, but Hassan is going to show a demo with a ROS system that he's actually connected from. So this is why, as Laura was saying, to be able to fully see the demo, you'll probably want to switch between the view that you're seeing from my screen now and Hassan's view. He will share his desktop so you can see the ROS commands going to our avatar system when we're doing the simulated robot part of the demo. For now, if everyone doesn't mind, I'll just share a presentation. We'll show a few slides to introduce this. So we are CloudConstable. Our solution is called Ava, the animated virtual agent. Actually, I should be more polite, and let me just see if I can switch cameras here so that you can see me as well. Here I am. Hi, everyone. So when we get back to the main demo that Hassan is going to start showing shortly, I will switch back so you can see that demo. But meanwhile, let's get back into the presentation. So our mission really is to deliver trusted, affordable AI technologies for enriched museum visitor experiences. And in a normal scenario, our animated avatar doesn't have to run on a robot. It can run just on a fixed station with a larger screen, as what we're seeing here. And it greets visitors and provides information about the museum. Excuse me. So we have basically the ability to interact and ask some questions, find out things about the museum and how to get around. And as well, we have a new digital content system that we're able to use to access digital exhibits. We're not really going to be showing that today, of course, because the main focus is on how would it work if it was on a robot. But even things like head gestures, nodding and shaking can be understood using the sensor system installed on our avatar solution. As you probably already guessed, in a military museum, we have a custom military camo outfit that the character can be set up with, but all kinds of customizations, of course, are possible depending on the requirements of a particular venue. I'm not going to show these now, but we do have some online YouTube demo videos that go into some of the features, and the first one on the left talks a little bit more about some of the Intel technology being used behind the scenes to make the solution work, including it runs on an Intel NUC, so we're running on an edge computer. It uses OpenVINO for running AI inferences on the edge device, and we're using Intel RealSense cameras for sensing. And I'll just skip past these videos for now. So how does this all relate to robots, and how do we, why is it that we're even trying to interface an animated avatar with robots? Well, this is actually being done as part of a research project led by York University, with participation also from Ontario Technical University, ourselves as one industry partner, and there's a couple of other ones, including a robotics company called Crosswing. And the idea is we're trying to use the animated avatar mounted on a robot, and hopefully a medium-sized screen or something close to the size of the screen that you're seeing in the demo today, or if necessary, a smaller screen. But the idea is that the avatar can be used to greet people, interact with visitors, relay orders to staff or sentries or security guards or what have you. And I think we've been quite successful in really engaging with people using the avatar on the robot. Now, the robot, of course, that's the kind of solution that is often run with ROS, and of course that's the reason we're presenting to the ROS2 AI integration working group. Just to give you an idea, the Center for Vision Research at York University has our principal investigator, Michael Jenkin, is associated with the Center for Vision Research. His lab is at York University, as well as another lab and another one of the researchers on the project, the Elder Lab, and I believe we have Helio, who's part of those labs and this project, on the call as well, should there be more questions about the robot part of this. But just to give you an idea, in the case of this particular scenario, we're imagining that we're not just on a mobile stand running our AVA solution that way, but we're actually on a mobile robot. We've got it set up to work that way in a couple of different robot scenarios on the SentryNet project. And it looks similar to this, not exactly like this, but similar to this in that case. Now, in our ideal scenario, of course, we're running ROS2, but actually on the SentryNet project, they're mostly running ROS1, I believe, on the actual robots in that project. The scenario we're talking about, though, involves the the robot in a space like a museum. So it might be somewhere like where we are today. And the idea is that the robot and its onboard sensor systems identify someone that we need to talk to, the robot needs to talk to. So the idea is the robot should approach them and then trigger our avatar system to actually talk. So how does this work? Well, as I mentioned before, we're running our avatar system on edge compute, specifically running on Windows, and we use Unity for rendering the 3D animation, running the animated character. We also have a vision subsystem in the background running a custom C++ app, including OpenVINO for accelerated inferences. The communications between those systems is via an open source asynchronous messaging library. And then the part where we're talking between ROS, in this case ROS1, and our avatar uses the TCP connector from the Unity Robotics Hub, which basically is written in C# with some Python. And of course, it's important to note that while in our demo scenario, we're using ROS1 to simulate the ROS1 based robots used in the SentryNet project, the Unity Robotics Hub and TCP connector solution also works with ROS2 with simple configuration changes. So are there any questions on the presentation so far? I'm going to take that.
Michael, I have a question here. You talk about performing some inferences on the edge that
Yes.
you use OpenVINO for that. So what are those inferences about? I mean, what are you inferencing on the edge Windows device?
So in our case, the avatar system is trying to communicate with a user in a natural way. So one of the things is we're looking for a face, and we're trying to see if there's a person who wants to interact with us. Actually, based on where the face is in the field of view of the camera, we're also checking how far away the face is, so that we can figure out, are they within normal conversational range. We can set that parameter, typically something about 2 meters, within 2 meters of the avatar system. And we're trying to make virtual eye contact with our users. So depending on where the human face is, the avatar looks one way or another. Also, we're detecting some nodding or shaking of heads if we ask questions and are getting a yes or no answer. So we're using the head pose model for that as well. So all of those things are running on the edge device. Now also, of course, we're running some speech recognition algorithms, and in this case we're using Azure Cloud for that, so that part doesn't actually run on the edge device right now.
Okay, thank you.
Any other questions?
Do you have any, I mean, it's anything regarding natural language processing or?
Yes, and that right now is also based in Azure Cloud. We're using some Azure services for that. Now there are some available that could run in OpenVINO. We haven't tried those yet, but that's something we are interested in experimenting with at some point in the future as well.
Okay, no more questions from my side. Thank you.
Anyone else? Hassan is still setting up over here, I think. We're almost ready. Just give me a minute.
Hi guys, so I'm just going to be presenting the demo we have, and in our demo we're going to have like 2 different scenarios. So we're going to have one scenario where it's going to be like random visitor to the museum we're at. The visitor is going to walk up, ask a couple questions, and then leave. The other scenario is going to be where you have a commander or a corporal of the military. They walk up, and then our avatar says like, "Oh, you're needed somewhere immediately," and then you leave. So the purpose is from the ROS perspective, we're going to send a message to the avatar. We're going to publish to a topic called utterance topic, and then the interaction is going to happen. And at the end of the interaction, we're going to send a message. The avatar from the avatar side, we're going to send another message, which is a state topic. So that's going to be published once the interaction is finished. So I can just share my screen showing you guys sort of how it's going to work. So present now. So I'm going to start Ava, and then basically on the left side, you're going to see this is like the ROS like master, the TCP endpoint is being launched here. And the top right corner, I'm going to send like a utterance message with a specific index. And from like, if it's like the specific index matters in this context. So if I send 0, it's going to be for like a museum visitor. If it's like something other than 0, it's going to be for a military commander or corporal is going to visit and they have to leave right away. And at the bottom right, you're going to see a state message being sent once the avatar, the interaction is finished. So without further ado, I'm going to start the avatar system. So when the avatar system starts, on the left side, you're going to see that a connection has been established, which will take place in a few seconds approximately. So yeah, you saw
for those
that.
watching remotely, you can pin if you wanted to see the avatar running, pin my window, or if you want to see the ROS command line and communications running, you can pin Hassan's window.
Yeah, and so I'm going to send the message at the top right, utterance of index 0. And once I do that, you'll see the interaction. Mike, are we ready to go on the camera side?
I'm ready to go. We're running.
See you later.
Thanks for coming. Bye.
I'm Master Corporal Lana, the animated virtual agent for the Ontario Regiment Museum. Welcome to the museum. How can I help you?
Tell me about the museum.
Please have a look around. There's lots to see and do here. The museum covers the history of the Ontario Regiment from its establishment in 1866 to the present day.
What is going on at the museum today?
There's a lot going on today at the Ontario Regiment RCAC Museum. The schedule of events is showing now. I hope you have a great day in the museum.
Thank you.
You're welcome.
Now we have to hope the state message comes through. There it goes. Yay!
And once I left, you see at the bottom right corner screen, you see that state message is published, which means that the interaction has ended. And so this was just the visitor scenario. And now we want to show the scenario where Mike is going to be corporal and he's going to be needed at a base and he has to leave immediately. So this doesn't include as much interaction, but we can just do that now.
The idea here is we wanted to show a couple of different scenarios depending on how the robot performs, and Helio may have an opportunity to share more about these scenarios. But the robot is actually able to identify people in certain scenarios if they're a known staff member or part of the team, or it might not recognize you and it might then identify you using utterance index of 0. That means we don't know who exactly you are. So in our more complete demo where we actually have a robot running around, it can actually look at the different people in a room and decide if it knows somebody or not, and if it's set up that it needs to find somebody to give them an order or something like that, which is the scenario we're going to show you now. The robot would find the person in the room, roll over to them, and then engage in a conversation similar to the one we might be ready to show right now. Are we ready to start, Hassan?
Yeah, we're ready to start. So Mike, whenever you're ready, you can go in front
I'm
of
going to
Ava.
move over and be the known person that we're going to be finding.
Immediately.
All right, I'm on my way. Thanks.
Yeah, and now she left. Mike left. Oh, there's a slight glitch, but the same message basically WebSocket closed, but the same message should be sent right after as you've seen before. So that was pretty much our demo scenario. Does anyone have any questions, or does Mike want to add anything?
I'm glad it worked. And I guess, yeah, we just should take questions if anybody has any. Laura, do you want to take it back then and continue if there's anything else to add on the agenda for today?
Very interesting, Mike. So, have you finished? So,
Unless there's any
I
more
think that-
questions, that's it.
I think that we don't have any questions.
All right. Well, thanks
Okay.
everyone for your attention.
Thank you very much for coming to the working group. You are very welcome. Okay, see you next time.
Cheers, everyone.
Okay, so thank you very much for all the attendees. And this is everything that we have today. So we finish now, and we hope to see you in the next AI integration working group. Okay, so bye, and thank you very much.